In this video, we will be measuring the percent ionization for a weak acid. So the Ka of a monoproduct weak acid is 7.5 times 10 raised to negative 3. We want to find the ionization of a 0.135 molar solution of this acid. And so let's get started. So we will draw a rice or an ice table. So the weak acid is HA, and it's going to be aqueous. And it will break down into H plus aqueous plus A minus aqueous. So we're given that the percent ionization of 0.135 molar solution of this acid. So the concentration that we have given is 0.135. To begin with, we don't have any product, so 0, 0. Next, we will do the change in concentration. So the reactant will be minus, and we have one of it, so minus X. We have one of this and one of this, but it's product, so it's going to be plus X and plus X. So the equilibrium, we would get 0.135 minus X. This would simply be X and X. So Ka is equal to, we have H plus, the product, times A minus, the product, divided by, and so this right here will equal X squared divided by 0.135 minus X. And so Ka in our given problem statement said it was 7.50 times 10 raised to negative 3, and this will equal X squared divided by 0.135 minus X. So we will want to solve for X, and so if we multiply this by each number, we would get, so 7.5 times 10 raised to negative 3 times 0.135 would give us 0.00100125, and then this number times negative X would simply be the same, but minus 7.50 times 10 raised to negative 3x, and this will equal X squared. If we rearrange this a little bit, we would get X squared plus 7.50 times 10 raised to negative 3x minus 0.00100125, and now we will use the quadratic equation. So X is equal to minus B plus or minus the square root of B squared minus 4AC divided by 2A. So we would get negative 7.5 times 10 raised to negative 3 plus or minus the square root of B squared, so this number squared, so 7.5 times 10 raised to negative 3 squared, minus 4AC, so minus 4 times A is simply 1, times C, which is this number, so negative 0.00100125, close parentheses, and then this whole thing divided by 2A, A is 1, so 2 parentheses 1, so it's simply 2. And so using this formula, we would get that X is equal to 0.0285 and negative 0.036. We ignore the negative and focus only on the positive. So the percent ionization of the weak acid will equal, and so we would get, so at equilibrium we got this number 0.0285, and initially we had 0.135, and then we multiplied by 100%. And so the percent ionization will equal 21.1%. And that's all we need to do for this problem.